Okay, so the last question I've got on this page is use the standard enthalpy change of formation values given in the table below to calculate the standard enthalpy change for the reaction. So as in the previous video in the questions, enthalpy change of the reaction is equal to the change in formation of products minus the enthalpy change of formation of reactants. So we've got all the values in here. We're trying to find this. So it should be straightforward. So all the products we've got is HNO3, and HNO3 is minus 176. But we've got 4 of them, so we have to times it by 4. And then we take away the standard enthalpy change of formation of all the reactants. Nitrogen gas is just the element itself, so the standard enthalpy change of formation is 0 for this one, and it's exactly the same with oxygen, so we don't even consider it. The only thing we've got on this side is hydrogen plus oxygen, which gives us water, and the standard enthalpy change of formation for this is minus 242, but we've got 2 waters, so we've got to times it by 2. Now we just gotta add up all the numbers and we're done. So that's minus 704, and then we take away minus 484. As you know, minus and a minus is plus, so it's minus 704 plus 484, which gives us a final answer of minus 220 kilojoules mole minus 1. And that's it. So here is the next question. Calculate the standard enthalpy change of formation of carbon monoxide in the following equation. So the basic sentence we've got to remember is that the standard enthalpy change of reaction is the standard enthalpy change of formation of products minus the standard enthalpy change of formation of reactants. Doesn't matter which one you put first. As you can see, I've changed the symbols a little bit, but that's fine. So we know the standard enthalpy change of reaction is minus 23. What we also know is the standard enthalpy change of formation of the products. For iron, it's an element itself, so the enthalpy change is 0. For carbon dioxide, the enthalpy change is minus 394. We've got 3 carbon dioxides, so we do 3 times minus 394. Then we take away standard enthalpy change of formation of reactants. In this case, it's the Fe2O3, which is minus 826, plus 3 carbon monoxides, which we don't know, and we're trying to find it. So it's minus 23 equals, this equals minus 1182, and then minus and a minus 826 equals plus 826, minus and a plus 3 carbon monoxides is, minus 3 carbon monoxides. Now we just combine it, these two numbers, which gives us minus 356 minus 3 carbon monoxides. When we take this over for it to be positive 3 carbon monoxides, we take this and add it, which gives us minus 333. And then we're just going to take this 3 over to this side, divided by 3, to get the standard enthalpy change of 1 carbon monoxide, because this is what the question asks us to do. Find an enthalpy change of formation of carbon monoxide, 1 mole of carbon monoxide. And this is 111 kilojoules mole minus 1. Next question is a writing question, and it says state what is meant by the term standard molar enthalpy change of formation. So we know what enthalpy change of formation is, and molar just means 1 mole of it. So what the mark scheme would look for is 1 mole of a compound is formed from its constituent parts. And you've got to include the standard states and conditions needed. What constituent means is just parts of a whole. So when 1 mole of a compound is formed from the parts, from the elements that the compound forms. So as we had like C6H12, the constituent parts would be the carbon and the hydrogen. So it has 2 constituent parts. That's what they're looking for. The next question says, write an equation to represent the standard molar enthalpy change of formation of water in gaseous state. So as always, we put water, the product, on the right hand side. We draw an arrow and then just see what constituent parts the water has. So it's obvious it's hydrogen and oxygen. Both in gaseous forms. We have to form 1 mole, so we can't put any big numbers on this side because it has to be 1 mole, not more, because that's what the standard enthalpy change of formation is. So we only need half of oxygen. And the last question that I've got for you is write an equation that represents the standard enthalpy change of formation of ethanol. So, you know what ethanol is. It has 2 carbons, it has 5 hydrogens, and an OH. And this is a liquid. What you've got to do next is find all the constituent parts. So it's carbon plus hydrogen plus oxygen. Oxygen and hydrogen go in pairs. You can see it's only 1 oxygen on this side, and you can't put any big numbers here because 1 mole has to be formed. So we only need half of oxygen. You've got 5, 6 hydrogens here, and you got 2 there. So you've got to put 3 in front, and you got 6. Now we've got 2 carbons on this side, so just put a big 2 on this side, and the equation is balanced. We've got to remember is to put all the states in, because that's what the standard enthalpy change of formation is. It has to be all in standard states. So you've got to remember to put them down, because you might lose marks by not putting them down. Okay, so that was the last question I prepared for you for this video. So remember, everything I show you are my techniques and ways of learning and revising. If you have any questions about my videos, please comment or email me. I will leave the link in the description box below. Also, if you have any comments about the quality or content of my videos, please also leave them under this video. Thank you. Like, subscribe, and see you soon. Bye.